Hello and welcome to Creating a Custom Environment with Gymnasium. I'm here today to add one more tool focusing on learning environment to your development and research arsenal. And I guarantee you that if you are a beginner in this field like me, you will have a great start with this library. First, we will briefly introduce reinforcement learning and Gymnasium, as well as its basic usage. After this, there will be a guide of how to create a custom environment and a little bit of next step after you know this too. So let's begin with what is reinforcement learning? Those who are familiar with the concept of machine learning may have heard about reinforcement learning as a semi-supervised learning. Essentially, reinforcement learning is learning what to do, how to map situation to action. Let's give you some example of what kind of problem reinforcement learning try to solve. In our beloved game, like chess, giving a certain board setting, what is the best move we could make? With reinforcement learning, we can let the agent learn the game and tell us what the best move is. If we want to be better at this game, it is also possible to let the agent tell us what kind of move we should avoid. Furthermore, finding ways to do something better or more efficiently is also a reinforcement learning application. One of those is discovering faster magic multiplication algorithms, as described in this paper on a model called Alpha Tensor. This is very interesting for me because I learn in reinforcement learning in mostly game-like environments, which I am intuitively familiar with, not something like this. So after all, if you have some problem that can be expressed in terms of situation action mapping, it is okay to say that using reinforcement learning to solve these problems is possible when we can describe the learnable environment to the learning agent. After that, it will be time to figure out how to make it happen. From previous examples, you may have heard about learning agents and environment. These two are the main components of the general reinforcement learning framework. The concept of how agents learn is simple, just like the way we learn. We learn what we see. The agent will observe the environment and pick an action for the current situation. When the action is taken, the environment changes accordingly, and this will be repeated until the agent reaches its goal. During the process, the agent will have to learn which kind of action is best for the certain situation. However, the agent is not told which action to take, but instead must discover which action yield the most reward by trying them. And the reward part is the semi-learning part, because instead of telling the agent directly that its chosen action is right or wrong, we give a reward as a hint signal. In most cases, we may not be interested in only immediate rewards, but all subsequent rewards from beginning to the end. This introduces us to the two most important characteristics of reinforcement learning: trial and error search and their reward. Now you know about the reinforcement learning framework. For our tools today, Gymnasium is take place in this framework as an API that covers the gray area, which include environment, action and observation spaces, and a way to return the reward to agent. To be precise, the description of Gymnasium on its official documentation page is an API standard for reinforcement learning with a diverse collection of reference environments. I do completely agree with this. For the standard API part, I already showed you briefly what is covered. As for the collection of environment, I will give you some example of the kinds of environment that we can use without implementing them. There are five collections that contain several environments we can use, which consists of classic control, toys text, box 2D, musical, and athlete games. These are only environments that I picked as example from each collection. There are a lot more. If you are interested, you can learn more about this on the official website. as well as finding more environment like Flappy Bird game in the GitHub page. From the example code, it is not so difficult to use these environments. We can make and use environment directly using the standard API that Gymnasium provided. So the reinforcement learning algorithm and agent will have to pick an action as a minimal contact point for the certain environments where the action must be within the scope of the action space specified by the environment itself. Before we use Gymnasium, here is the information we should know. First is provide an API for all single agent reinforcement learning environment, not multi-agent. Second, at the core level, it mainly represents a Markov decision process. Third, it supports and tests for Python 3.8 to 3.11 on Linux and Mac OS. It does not officially support Windows, so it will take extra steps if you want to use Gymnasium there. And lastly, this is a fork of OpenAI Gym, where future updates and maintenance will be here. So if you still use OpenAI Gym, please consider migrating to this library. In case that we want to create our own custom environment, here are the things that we need to know. If we want to create a custom environment, we have to use this environment interface. In this class, there are three methods that are necessary to be implemented. First, the reset method. This method should be called every time a new episode happens. So basically, we use this to prepare and initiate before we start, and it will return initial observations and information, where observation should be something that agent needs to understand the environment, and information should be something else that not necessarily for agents. Second, the step method. This method contains a logic for what will happen after action is taken, and then update the environment accordingly. Similar to the reset method, it also returns observations and information, in this case, after action is taken. For additional return variable, there are rewards that give a hint to agent after it takes action. Terminated, which determine whether the agent reached the terminal state, and truncated, which determine whether the truncation condition outside the scope of MDP is satisfied. Generally, it is used for time limits, but in some cases, use this to tell that an agent is going out of the boundary of an observation space. So if terminated or truncated is true, we have to call reset method in order to start a new episode. Finally, the render method. If we don't need a GUI that shows what happens during the agent training or action taking, we don't really have to implement this. But if we want to use the GUI, then we can implement this with an additional GUI library. Generally speaking, Pygame is an alright option that we can use, and this three method is the minimum requirement for creating a custom environment. Let's give some example of custom environment that I created. So in this case, I want to replicate one of the example in the textbook called Reinforcement Learning and Introduction. The problem is that Jack has two core rental places, which have different core rental requests and return. These are independent variables that have Poisson distribution and expected numbers as specified. There are several conditions we must follow, but I will skip it for now. And lastly, the question is how many cards Jack should transfer from one place to the another place in order to maximize his profit. So of course, when we start, we have to inherit the environment class and implement those methods that we mentioned before. But before that, we have to initiate all the problem configurations, such as the number of maximum cores that a rental page can hold, rental cores, and transfer expenses. And then we must define observation and action space. In this case, we have two core rental places, and then the observation space should be a pair of the number of core into places. For action space, we can describe the action as the number of core transfer, where the positive number is the number of core transfer from A to B, The negative number is the number of card transfer from B to A. These two are discrete spaces, so we can define them like this. There are several types of spaces offered by Gymnasium, starting from the fundamental spaces like the ones I use to the composite spaces for more complex tasks. So please check it out and use the one that is suitable for your environment. For the reset and step methods, they are quite straightforward, but it is recommended that we define private functions that return observation and information. And in step method, the logic of the state transition should be specified here as well as reward calculation of function. For the render method, in my case, I use Pygame for GUI and make a render frame like this, where one side is current status of two current places and the other side shows the cumulative reward or profit. After all of this, I will have an environment that can be used as a control environment. As shown here, I use the same environment to compare naive agent that randomly pick action and agent that have a policy form policy iteration algorithm. And in the future, I can use this environment to train and compare the new algorithms that I learn. Now we know about the gymnasium and its basic usage, especially the environment creation. So for the next step, I do recommend you to study more about reinforcement learning algorithms, as in textbook I use called Reinforcement Learning and Introduction 2nd edition. This will give you the concept of reinforcement learning from the start. If you want to implement deep reinforcement learning like deep Q learning, stable bit light tree and TF agents are great start for implementation on PyTorch and TensorFlow respectively. If you want to work with multi-agent environment, PettingZoo is a multi-agent version of Gymnasium. It had a similar interface, so you don't have to learn new syntax that much. If you work with more advanced simulation, Gym-UnrealCV provides a bridge to connect Gymnasium to the Unreal Engine. And links to all of these are given in the description below. I hope that my contribution gave you some information, tools, and maybe some ideas that you can work with in the future. That's it for today. Thank you.